Fractions is where we're going to start. So I want you to take out some paper. I am going to give you 3 minutes. 3 minutes to work on these 4 problems. 3 minutes to work on these 4 problems. Now, when you look at these 2 right here, compared to these 2 right here, what do we have to do here?
You just...
Common denominator. Do we need a common denominator here? No. Go for it. It is, but you're going to leave it 5/4. Yeah, but you're fine. You're fine. That is correct.
My bad. Sorry.
No, you're fine.
Step over ahead myself.
You're fine. A lot of times these things are just things we've forgotten, and we've got to remind our brain how to do them.
Let me see here. That's... If I remember correctly, if it doesn't have
Over 1. It's over 1. Yes.
So I would division is copy dot flip, right?
Yes. I was thinking change flip. The copy dot flip works too. And we'll talk about in just a second mathematically what we're doing. Okay, let's get started. We're going to start talking about the first one. What we have here is we have 1/2 plus 3/4. Okay, and we've got a very common error that students make is they forget which operations they've got to have a common denominator and which they don't. Addition and subtraction is when you have to have that common denominator. So what you're looking for is you're looking for a number that both 2 and 4 go into. So we start looking at multiples of 2 and multiples of 4. What is my least common denominator for 2 and 4? 4. 4 is. Okay? So then I am rewriting each one of these fractions in terms of 4. I'm writing each one of these fractions in terms of 4. Those are called equivalent fractions. So I've got to find an equivalent fraction to 1/2. So the way that I do that is I look at this 2 right here that's in the bottom, and I say 2 times what gives me 4? 2 times 2. So 2 times 2 gives me 4. If I do that to the bottom, what do I have to do to the top? Same thing. Okay? So here I'm going to have times 2. So I have 2 over 4. 1/2 and 2/4 are equivalent fractions. Okay? Now, what do I multiply 4 by to get 4? 1. Okay? So I'm not going to have to do anything here. My 3/4 stays 3/4. And when we're lucky, that happens. So 2/4 plus 3/4 is 5/4. How many of you left it 5/4? Did anybody change it to 1 1/4? Okay. 1 1/4 is correct. It's just as correct as 5/4. Okay? In algebra, you typically always leave it 5/4. Okay? So you don't have to change it. The reason that we don't change it is for when we do rationals. And so getting in the habit of leaving it improper is important. Now, me telling you that you can leave it improper is not me telling you you don't have to simplify. Okay? So I want you to look at this. This is 5/4. What's the difference in this improper fraction and this improper fraction?
It's basically 9. It's basically 9.
Which one's not simplified?
The 18/4.
Correct. 18/4 is not simplified. It's improper, but it's not simplified. What goes into both of these? 2. So this simplifies to 9/2. It's still improper, but it's simplified. 5/4 is improper and simplified. This is not simplified. It's just improper. So I want you, so a lot of times students will come back and they'll say, Alicia, you said we didn't have to simplify. Nope, that's not what I said. I said you didn't have to change an improper fraction to a mixed number. You always simplify if given that opportunity. Okay? Now, we're subtracting fractions. 2/3 minus 2/5. What's my LCD?
The 15.
15. There's a couple of different ways that we can get to 15. The laziest way is that we multiply 3 times 5. Okay? 3 times 5 is 15. You will always get a common denominator if you multiply your two denominators together. You always will. Okay? It'll be common. It may not be the least common, but it'll always be common. The problem is the bigger numbers you deal with, the more opportunity there is for a mistake. So, what I would encourage you to do is I would encourage you to look at these two. We've got 3 and we've got 5. Which one's bigger? 5. So start thinking about your multiples. 5, 10, 15, 20. Okay? At some point, one of those multiples is also going to be divisible by this one. Okay? And so that's when we stop. That's how we got to 15. It's not wrong to multiply those two together, but you're going to be dealing with larger numbers than you have to sometimes if you always do that. Okay, 3 goes into 15. How many times? 5. So I'm saying 3 times 5 is 15. What's 2 times 5?
10.
Good. So we have 10/15. Those are equivalent fractions. 5 goes into 15. How many times?
3.
So then I multiply the 3. Okay? What is 10/15 minus 6/15?
4/15.
4/15. Okay. Now, very often when we move to multiplication of fractions, students will say, but Alicia, I have to find a common denominator. When you're multiplying and you are dividing, you do not have to have a common denominator. This is a whole number right here. Okay? This 3. What can I write that over?
1.
Good. Okay. So when I multiply fractions, I multiply the top, 1 times 3, and then I multiply the bottom, 2 times 3. I must have changed my numbers because these are not the same numbers I get. I'm looking like I made mistakes because when I did it in my other class, these are not the same numbers. Yes?
But if it's 3, it would be 3 over
It is 3. I knew that I did something wrong. Thank you. I was like, what am I doing wrong? Hey, I make mistakes all the time, so correct me. I was like, that just doesn't look right. Okay, 1 times 3 is?
3.
2 times 1 is?
2.
Good, that looks much better. That makes me happier. Okay, if you think I'm wrong, you tell me.
I'm still confused on the division part.
The division, we haven't done division yet.
Oh. Right.
Yeah, we're about to do division.
Yeah, that one confuses
That's
me.
okay, that's why we're going to do it right now. Okay, so we've got 3 over 2. Any questions on the multiplication? Okay, I'm going to erase everything on this board. Is that okay? Okay.
Yes.
Okay. So now we are dividing fractions. So I've got 1/2 divided by 3. Now I already messed up royally. What do I put the 3 over? 1. 3 over 1. Now, I have always heard keep, change, flip. Okay? I'd heard the other one. What was it?
Copy dot flip.
Copy, dot, flip. Okay, copy, dot, flip.
Oh, okay.
Okay, now, that's not what you're doing. Okay, those are cheats. It's slang to help you remember how to do it. Does anyone know what we are doing when we are dividing fractions? Multiply by the reciprocal. That's what we're doing. Okay? When we're dividing, what we're doing is we're multiplying by the reciprocal. Keep, change, flip, and copy, dot, flip. That's just to help us remember what to do. Okay? So my 1/2 stays the same. My division becomes multiplication. My 3 over 1 becomes what?
1 over 3.
Good. Okay. Now I follow my multiplication pattern. So 1 times 1 is? 2 times 3 is? Okay. There we go. So that is a refresher in fractions. Is it coming back to you?
Yeah.
Do you hate it as much as you did a couple days ago?
I love fractions.
Good. Now is a good time for me to remind you that you can't use a calculator in this class at all. Okay?
Yeah.
So it is to your benefit not to do your homework with a calculator. Okay? You don't want to sit down and start using a calculator, or not using a calculator for the first time on the day of the test. Now, these are your rules for adding real numbers. Now, you're going to have access to this in Canvas, so I really wouldn't spend a lot of time writing this down, okay? I talk about my son all the time, so let's talk about Bradley. Now, the first two, when you multiply, we're adding. When you're adding a positive number and a positive number, my son likes to spend money like you would not believe. Loves it. He likes to spend my money like you wouldn't believe. Okay, he gets an allowance. So if he's got $10 in his checking account and I give him his $16 allowance, what happens? He has $26. He had $10 positive, and then he had I added $16 to that, so he has $26. He likes it when it's in the positive. But he doesn't have a job, so he doesn't add to his checking account very often. What happens way more often is he might be in the hole to me. What does it mean when he's in the hole to me? He owes me money, and that happens a lot. I think that's my fault, right? If he owes me a lot of money, it's probably my fault. So let's say that Bradley owes me $10. So he's in the hole, $10. Okay? And then he decides that he needs to put gas in his car. So I give him $16 to go put gas in his car. How much does he owe me now? He owes me $26. Okay? So he had a negative amount. He took another negative amount and added to that. And so he is in the hole, negative $26. Okay? That's what happens most of the time. Now, here we've got a positive and then a negative. This is when we get our financial aid. And maybe you got $1,000 for financial aid. So you have $1,000 in that financial aid account. And then we go to the bookstore. Yes. And we might spend $230. Okay? So we had a positive amount. Then we added a negative amount to that. We've taken it out. Negative $230. That's what's happening when we've got one positive and one negative number. Now, this is how we kind of define it, and it's a little math wordy. I want us to talk a little bit about absolute value, and I want us to come up with a chart that's going to help us with our positive and negative numbers when we're adding and subtracting. Now, here is a number line right here. Now, I have not had one class get this right, so you guys are going to do it. You're going to be my class. Okay? What is absolute value? Who can tell me what is absolute value? Yes, ma'am.
The absolute value for that one is 5.
Okay. And you're correct. The absolute value for negative 5 is 5.
Because you don't have the negative doesn't work.
Okay? So if I've got a negative number like negative 5, I'm going to throw the negative out.
Yeah.
Okay? And you are correct. The absolute value of negative 5 is 5. Okay? But what is absolute value? Okay, I've got an anything positive. Yes, you're the only person today that's gotten that right. Okay? Absolute value is the distance a number is from 0. That's why we're always talking about it being positive. Because it doesn't matter which direction I walk or what I do, a distance is going to be positive. Absolute value is the distance a number is from 0. So negative 5 is 5 slots from 0, and positive 5 is 5 slots from 0. Okay? So that terminology, and everybody gets so irritated at me because I want you to use the proper terminology when we're talking about adding positive and negative numbers. So let's look at a chart, and this is a chart that I would keep beside you until you are remembering all of these things. Okay? You've had a positive number for a positive number for a very long time. Okay? Positive number plus a positive number. What is our answer when we have a positive number plus a positive number? It's always going to be positive. Okay. But what I did to get my positive is I added those two numbers' absolute values. Added their absolute value. That's what I did. Now, if I have a negative number plus a negative number, okay, that's Bradley owes me money, then he needs more money than he still owes me. So it's a negative amount plus a negative amount. What's my answer?
A negative amount.
It's a negative amount. Okay? But again, what I have done is I have added the absolute values of those two numbers. Okay? That's what I've done.
So wait, I don't understand how adding the absolute value of two negative numbers give you a negative.
Okay? So, think about my sweet son. He is negative $10 in the hole. Okay? Then I give him an additional $16. Okay? So he is now negative $26 in the hole.
I mean, well, I get it if you feel like that. But
I know.
the way you explained it was that the
Okay.
absolute value of two negative numbers would give you a negative, but I thought the
Okay.
absolute value.
All you're doing is you're adding their absolute value. Okay? So here, what's the absolute value of negative 10? 10. What's the absolute value of negative 16? 16. So I am adding 10 plus 16. Okay? But my original problem was a negative plus a negative. So what's my answer going to have? Negative sign or a positive sign?
Negative.
Negative sign.
Basically, you
So you're really thinking about two different things. The first thing that you've got to determine is whether or not you've got to add their absolute values or subtract their absolute values. And if the signs are the same, you're adding their absolute values every time. Every single time. Positive plus a positive, you're adding their absolute values. My answer is positive. Negative plus a negative, you're going to add their absolute values, but your answer is going to be negative.
See, this is interesting because when I learned about this in like 7th grade.
Right?
And they didn't teach it like that.
Right.
And I guess it's the way it sounds.
Sure.
It sounds weird because I've always learned negative. They just say a negative plus a negative is a negative.
And a negative plus a negative is a negative, but I'm trying to get you to think about the why so you'll remember it. And I can go off on my little soapbox here. If you're on Facebook or Instagram, there was an order of operations problem that went around a couple of weeks ago, and people got 16 and people got 1. And people were like, but PEMDAS, PEMDAS, PEMDAS. PEMDAS is not the order of operations. PEMDAS is something that we use to remember the order of operations. And because we didn't learn to understand the order of operations, we remember PEMDAS incorrectly. And so then we have this national crisis of is the answer 16 or 1. So what I'm doing here is I'm trying to get you to understand why. Why what's going on. Okay? Because I think that's where sometimes we forget. Okay. Now, when I got a positive number and a negative number, okay, that's Bradley has $15 in his checking account. He spends 20. So 15 plus negative 20. He's got negative $5. The bank's going to be calling me. And I'm going to take his keys and we'll go on from there. Okay. What did I do with their absolute values when I've got a positive and a negative? Okay. So that's where your answer is going to be. Okay. So your answer is you are going to take the sign of the number with greater absolute value. And my students for years complained to me about this. Take the sign of the number with greater absolute value. Because you learned, take the sign with the bigger number. Every single positive number is bigger than any negative number. So I can have positive 1 and I can have negative 10, and positive 1 is bigger. Okay? So that's one of those things that it just makes us a little uncomfortable, all the math language that we use. So you're not taking the sign of the bigger number. You're taking the sign of the number with the greater absolute value.
Wait, so if it was in reverse and if it was negative 1 and positive 10, then you would take...
Positive 10 is the bigger number. The positive number is always bigger than the negative
But
number.
you said you would take the sign with the biggest absolute value.
Correct.
So, but technically, in both scenarios, wouldn't it still be 10?
Okay, so if I had positive 10 and negative 1, which one has the greater absolute value?
10.
10. So my answer is going to be positive.
But if you reverse it and say negative 10 and positive 1, it still would be 10, right?
No.
This is your greater absolute value.
It would be
So my answer would be negative 9. So I take this sign because this is the number with the greater absolute value.
Yeah, easy problems like this I like. It's just the other ones.
I know. Now, when we did each one of these, did I add their absolute values or did I subtract? Subtract. Okay, so that's what I'm doing here, is I subtract their absolute values. Now, as you are working on homework, this is probably something that you might want to have in front of you, this little chart right here. Okay? So if you want to take a picture, that's fine. If you want to star what you've written down, that's also fine. Okay? I'm moving screens. Ready? Okay. For the sake of time, we're not going to do the 3 minutes on this one. We're going to do these together. Okay?
Oops.
So for the first one, I've got negative 6 plus negative 8. I have a negative and a negative. So you're really deciding two things every time you're faced with one of these. You're deciding, is my answer going to be positive or negative? And am I adding or am I subtracting their absolute values? When my signs are the same, do I add or do I subtract? I add. When my signs are the same, I add. Okay? So the absolute value of negative 6 is 6. The absolute value of negative 8 is 8. So I add those together. When both are negative, what's my answer? Negative. Okay, so negative 6 plus negative 8 is negative 14. Now, for B, we're going to have to think back back to our fraction rules. Now, for these right here, I recommend you change them to improper fractions. It's just better. You just go ahead and get them in improper, and then you can deal with them. Does anyone remember how to make that improper? If I've got 6 3/4, how do I make that improper?
You multiply the denominator and the whole number and add.
You got it. That's exactly right. Okay? So we take our 4 and we multiply that times our 6. So our 4 and our 6 is going to be multiplied together. Okay? Then, once I get that, then I add 3. So 4 times 6 is 24, plus 3 is,
24 plus 30
what did I say? 4 times 6 is what? 24, plus 3 is 27. You're my last class of the day, so I make lots more mistakes on my last class of the day. Okay? Then our next one is going to stay negative. Just go ahead and write that negative down. Okay? 2 times 2 is what? 4. 4 plus 1 is? Okay. Now, do I have a common denominator?
20 is
My common denominator is?
4.
It's not, it's 4. Now, did anybody say it was 8, just out of curiosity? Okay. You could have multiplied 4 times 8. 8 is a common denominator. It's not your best. Okay? It's not your best. 4 is my common denominator. How? Okay. 4 goes into 4, and 2 goes into 4. So we're looking for a number that goes into both of those. That's why 4.
So if you would have did 2, then
So my common denominator here is 4. Okay? How many times does 2 go into 4? 2 times. So I've multiplied my denominator by 2. So then I multiply my numerator by 2 also. What's 27 and negative 10?
16 over 4.
You're very close.
No,
It's
17.
17.
Sorry.
Why is my 17 positive and not negative? Yes, because 27 has the larger absolute value.
My mind is right now.
That's okay.
Don't pay attention to me.
You're fine. You're
Pay
fine.
attention to me.
You're fine. 14 and negative 21. We're adding those two together. What do I get? C, negative or positive 14 and negative 21.
Negative number.
It is a negative number. Tell me why it's a negative number.
Because the biggest one is the negative.
Okay, because the absolute value of negative 21 is greater than the absolute value of 14. Now, I've got a positive and I've got a negative. So what do I do with those values? Subtract. Okay, that's how I get my 7. So my answer here is negative 7. Now, if you can see this one right here, I've got a negative 72.4 and a positive 72.4. Okay, it's 0. It's 0. Okay. Now let's talk about subtraction. Can I go off this screen? Okay. I ask that all the time, so don't hesitate to tell me when I can. Now this is some mathematical language here, and I think it's always good to show the mathematical language. Okay? Because this is what we're doing. If A and B are real numbers, then A minus B is equal to A plus negative B. Okay? That's what we're doing. Subtraction, you're adding the opposite. I like this right here. I like what this says right here. A minus B is equal to A plus the opposite of B. I do like that.
Yeah, which is meaning if it's
Okay? I do like that. Now, let's talk about some tips on what we do. So when we are subtracting, there's really 4 steps, and we're adding the opposite of these, what we're doing. The first step, you are going to keep your first number the same. That's what we're going to do. Okay? The second thing that we're going to do is we're going to change the subtraction sign to addition. Okay? Our third step, make second number its opposite. And then our fourth step is follow addition rules. Follow addition rules. So what we're doing is we are taking subtraction and we are turning it into addition. That's what we're doing, and then we're going to follow the addition rules. Okay? Okay, can I move off the screen? Okay. Okay. So, we're going to do these together just for the sake of time. I guess I talked too much at the beginning of class. I've got 7 minus 9. 7 minus 9. That is going to become 7 plus negative 9. Okay? 7 plus negative 9. Yes?
Would we have to do this on the test by any chance if it's a 7 minus bigger, if it's a small number minus a bigger number, do we have to do that do we have to change it on the test, or can we just leave it the same and just...
As long as you know who the negative sign belongs to, because in this one right here, where students make mistakes is they don't know who that negative sign belongs to. As long as you keep that negative with the 9, when you start moving things around, I'm fine. But that's the danger, is that students don't keep that negative with the number that it belongs to.
Yeah, it's fine. I mean,
Okay.
I know
No,
what to
you're
do
good.
in some of these types of situations.
You're good.
So-
Okay. 7 plus negative 9, greater absolute value. Negative. Okay, am I adding or subtracting? Good. Okay. Now, for B, I've got negative 5 minus negative 13. Now, you were probably taught for the double negative, you just make it a positive. Were you taught that?
Yes.
Okay, but let me tell you what you're doing. That is correct. The double negative, you just make it positive. That's true, because a negative and a negative make a positive. But what you're doing is you are changing this to addition, and then you're adding the opposite. That's why that negative becomes a plus. So I think something that's happened is we just memorize things that our teachers told us to memorize. We don't fully understand why we do those things. And so then we sit here at the ACT or in this class and we're like, oh, I can't remember the rule. I can't remember the rule. So if we understand what's going on, we don't always have to remember the rule because we understand we're just adding the opposite. Okay? So here I've got negative 5 and positive 13. So what do I end up with? 8. Okay? Now C. C is 6.1 minus negative 14 plus 2. So again, I've got this double negative, so I add its opposite. So I have 6.1 plus 14.2. You're not using calculators. You're not using calculators, so you have to remember how to add decimals. What's the important thing when I add decimals? Good. What do I have to line up? The actual decimal. So I've got 6.1, or 6 1/10, And 14 2/10. It is 20.3. Okay? So you bring that decimal straight down. 1 plus 2 is 3. 6 plus 4 is 10. 1 and 1 is 2. So my answer to that is 20.3. I highly recommend that you do not do your homework with a calculator. Do not do your homework with a calculator.
And this is easy. It's the harder ones that I feel like would be
That's
hard
true.
to do without calculator.
That's true. Can I erase this so we can do our fractions?
Yes.
Okay. Okay, so now we have a fraction one. Now, what I tell students to do is anytime they're dealing with a negative, I tell students to go ahead and move that negative to the numerator. Okay? Go ahead and move that negative to the numerator. It helps you keep things straight. So when I rewrite this, I'm going to rewrite negative 7 over 8. Negative 7 over 8. Negative 7/8 can be written with the negative in front of the whole fraction. It can be written with the negative in the numerator. And it also can be written, although you don't see it very often, with the negative in the denominator. Does anybody know the one way it can't be written? With two negatives. If you say negative 7 over negative 8, what have I done? You've made it positive. Okay? So that's why I tell students to go ahead and move that negative to the numerator, because you're just going to keep it straight. What happens to this minus and minus? Okay? So my common denominator is going to be 8. Okay, 4 goes into 8 twice.
2 over 8.
So 2 over 8. My negative 7/8 has the higher absolute value. So I take that sign and I get negative 5 over 8. Okay? We're not done, so don't start packing up. Okay. So, I think that when we're remembering how to add and subtract positive numbers, that it really is the addition and subtraction that's more challenging. Fortunately for us, the multiplication and division follow the same set of rules. Okay? They follow the multiplication rules are exactly the same as the division rules. Multiplication and division are inverses of each other. So, here we've got some definitions of what we're doing when we are multiplying numbers. The product of two positives or two negatives. So that's if your signs are the same. If I have a positive times a positive or a negative times a negative, my answer is always going to be positive. Okay? If I have one positive and one negative, what's my answer always going to be? Negative. Okay, it always works like that. Now, I prefer to do a chart like this. So if I have a positive number times a positive number, what is that going to equal? Positive number. If I have a negative number times a negative number, what is that going to equal? Okay, now, that right there is where students get confused. Because what is a negative plus a negative? A negative. Okay? So I've had students argue with me about that before. A negative plus a negative is a negative, but a negative times a negative is a positive. Okay? Have you ever heard the two wrongs don't make a right? The two negatives do make a positive? This is what, if math people have children, this is what we talk to them about. My daughter rolls her eyes, my son still doesn't get it. So, negative times a negative is a positive. A negative plus a negative is a negative. So you got to be careful with that. Positive times a negative is always what? Always. Negative times a positive. always. Okay, the same exact rules apply when we divide. If your signs are the same, it's positive. If your signs are different, it's negative. Okay? Now, this shot right here, or wherever this is in your notes, and I'm going to move backwards. Let me find the other ones. This one for subtraction, and this one for addition. Okay, I would keep those close by. On Friday, we're going to talk about order of operations, so I definitely would do that too. Now let's do some multiplication super fast before you guys leave me. What is negative 6 times negative 7? 42. Positive 42. Negative and a negative. Okay? Positive 8 times negative 9.
Negative 72.
Okay. Now, I'm going to rewrite this. I'm going to move my negative to the top because it just makes it easier for our brain. What's negative 3 times positive 1? Negative 3. Did I mess up again? No, I didn't. Okay. What's 4 times 3? 12. Okay, does that simplify?
Yes.
Okay. As we move into rationals, we will have a whole conversation on being able to do that right there.
Wait,
Okay?
I thought it was supposed to go to the part where the half is. Sorry.
No, that's okay. I'm just not sure what you're asking.
That, you put the negative on the 3 when it was supposed to go to the half sign.
Okay, so I could put it in front of the 3. So I could say negative 3 over 12. I could put it in front of the whole fraction, like that.
Yeah.
Or I could put it in the bottom. Okay, but they all mean exactly the same thing.
Okay.
I always put it in the top, just because it helps us keep it clear.
Okay. I'm sorry.
You're fine.
I just
Okay.
messed up.
Okay, we will do order of operations, but this is what you can get started on. Page 40, numbers 3 through 25. Page 40, 3 through 25.